to everybody. I'm very happy to stay with you, and special thanks to Indian Women Association and all nice talks we have now. And I will try to do the link, saying that the rebalance you are proposing now is completely related to all situation we are seeing today. So we have natural services, we have environmental services, and last talk showed us the necessity to reimplant the many efforts to have mangroves growing again. So this is very meaningful for us, and the importance of cleaning water or talking and doing something related to our releases, to our garbage is very, very important. And that is why we are talking, why radiation? Why to think about irradiation related to environmental or our natural services. So daily, we have many pollutants emission in air, and especially in water, soil, and everywhere. But here, this figure is telling us about the pharmaceuticals. So we have many pharmaceuticals spread in the environment, even in drinking water. Okay, and this figure is a little bit related to ecotoxicity, because all what is related or is getting inside the river, the lakes, and the sea, of course, is damaging and is reducing biodiversity. And in this case, I like to see it's a wastewater treatment system common in Brazil and other countries that has some relatively big areas. And these wastewater treatment plants, they are, of course, another example of environmental services. But we can reinforce this service, putting oxygen, adding something in for microbials works more and more effectively. So in nature, the organic matter is reduced normally by biodegradation. But when we have a lot of pollutants, we have excessive organic charge, it is damage. So no working anymore. And then many types of wastewater treatment facilities where we can put our sewage, and then we can put our industrial effluents to be treated, and aeration, introduction of oxygen is part of it. And then we can use, and of course, all the world use the biological degradation or the activated sludge. And then these treated effluents grow to the nature again, to the rivers. And we have another big problem related to the solid residues related to this type of facilities. So when we think about radiation, this is electron beam irradiation here. And we, of course, we will apply it for water and dirty waters, because we can induce radiolysis. So we can have many different species and molecules from the contact and of radiation with water. Then we call it radiolysis, and it's very promising for persistent organic pollutants, right? And when we do the exposure of waters or effluents to electron beam irradiation, we work in terms of dose. That is the amount of energy I will give it to the materials I have to treat. So again, you say about 1 Earth and rebalance. It's completely right. And we have to think about our garbage, our air, water, and the technology will go into these areas, right? And in this case, we would say about the reduction or the reduction of water pollutants, especially organic compounds. And I will tell about something about ecotoxicity and why it's so important for keeping or for saving quality of waters. And some examples related to textile effluents, to dye cotton, for instance, tannery effluents to get the leather, industrial effluents, they are very related to surfactants, to solvents, to dyes, of course, to the microorganisms and other class of chemicals. And previous I showed the pharmaceuticals. So electron beam irradiation of pharmaceuticals, some examples to show you: fluoxetine, propanolol, dichlorophenol, and the mixtures, okay? And telling about this and the previous presentation, I should say that it is very imperative to think about water reuse in industrial processing, or we can call industrial reuse of wastewater. What does it mean? At least part of the dirty water produced by industry, it can be treated at the same place and reused in the process again, at least once, 2 times. It's very, very important. So when we talk about treatment technologies, I have to say about toxicity. So as I told you, by irradiation, I can get a very special species to be introduced in my system. And here, this is a very simple way to show electron beam, and it's gamma rays. And ozone oxidation is very useful today, but it's smaller systems and other catalytics and many combinations for we can call advanced oxidation process. And here is an electron beam accelerator when I can pass my material to be irradiated under this system. So this an electron beam accelerator out at my institution, IPE. So again, I can use radioactive isotopes as gamma rays, including you have one installation, one institute in India. For environmental purposes, we like to think in Brazil to use electron beam accelerators. Both of these irradiators were very useful and are still for health and for cancer treatment and for sterilization of material for health, right? Okay, so it is IPEN, our institute, and this is the entrance of a cobalt source irradiation. That means gamma ray. And this is our electron beam system where I can treat my material. And of course, all of them have special characteristics and it is very nice for one application or other application. We don't have time enough to discuss this here, but the material will stay with you. And the living organisms that are doing our natural services in lakes, in nature, in wastewater treatment facilities, and are important for food, we can keep them in laboratory, and we exposure them to our effluents in order to see how toxic, how is the charge in terms of toxicity that any type of effluent uh, is increasing to the system. And especially when I treat the effluents, I use this system for measuring how efficient is my treatment in terms of reduction of toxic charge. So this is a green algae, this is a Seridaphnia, this is a Daphnia similis, this is a luminescent bacteria, small fish, zebrafish, this is a rotifer, and this is a way how I do my exposure, varying concentration of effluent and how this is increasing mortality as I increase the amount of or the concentration of effluent. So again, this is a way where we can analyze the control, for instance, Daphnia similis, and at the same time, I increase the amount of my sample, I will losing survive, or I mean, mortality related to the samples. This is a way I do our small samples irradiation at the lab with a dynamitron accelerator. Sorry, in terms 2 liters at any batch. I can apply different and several doses. And for my experiments, I fixed the energy of the machine. The higher energy, the bigger amount I can treat at the one batch. And the release, as always, every place, the release, unfortunately, go to the rivers. That's why we are talking about this subject here, and the use of living organisms to measure, and including many countries has this type of toxicity assays for regulation or for limiting the release of pollutants to the rivers. So in this case is a data related to fluoxetine. Fluoxetine used for many treatments, and how we did the irradiation, and reducing with a very, very small dose the concentration of these pharmaceuticals, and of course reducing toxicity with daphnias. This is part of our job. This I can tell you about cotton fabrics and dyeing. It's a very important activity, I think, for Brazil and India. And we have this processing of dyeing cotton, and the very important colored residues or water, wastewater. And then here we have tried to decompose this reactive blue 222. Since the machines were used for dyeing cotton, the effluents were treated at Accelerator. Here we show you the reducing color reduction of effluent. And then in this experiment, we used the colored effluent again as a reuse to dye the cotton. So it's a small example of what we're starting doing with radiation in terms of reducing color from wastewater and reuse it in the cotton facility. And this is another example in terms of tannery wastewater. That is one, for me, it's one worst type of wastewater due to the large amount of organics, inorganics, chromium, and so many hard pollutants. But of course, we need the materials. We have the pills, the skins we have to use. So this is an example in Brazil, tannery raw effluents in a small city close to São Paulo. This is 77 cubic meter per hour in terms of effluents. And they use biological system, but it's very bad because when the charge or toxicity is very high, of course, the biological system works not good sense. It's fail and the effluence is very bad. So we are trying to use different advanced technology there to trying to combine with a biological system. I will only to show you the who works with effluence or effluence parameter can see by here that this effluent is very, very bad. And then you use the 10 and 20 kilograms in order to start working better. And now we are finishing one special project where we bought from Korea one small electron beam accelerator to be installed in this mobile system that will offer some equipment for wastewater characterization, and this can be showed to the special industries, and we can do it in a different scale, and in the plants, or we can move the unit to show for our sanitation company, for the textile industry, for pharmaceutical industries. So it's an example of our institution, our nuclear commission, our partners from industry, and other technical schools as a new project where we can have a new small accelerator inside the truck. This is an example to tell you, especially
Dr. Borrely, sorry to interrupt you. Just a couple of minutes more, please.
Okay, right. So it's an example of the use you guys in India have regarding gamma irradiators at Braba Atomic Research Center, especially here. They use it for improving seeds, inducing mutation with radiation, and having very effective seeds in a commercial scale. But also, I'd like to tell you that in this center, you use gamma for disinfection of sewage sludge. So the farmers can buy or can have small samples of irradiated sludge samples for using in agriculture, due to Braba Atomic Research Center. So I believe in education, communication, monitoring is very important, regulation and legislation for protection, and also technology. This is one of our students that is talking about many pharmaceuticals and using radiation for degradation them. And why searching treatment technology? This is very important because without knowing, we have our daily drinking water with the pharmaceuticals, and water consumption is always increasing. Also, toxicity measurements is very important. And we believe that our advanced technology or other technologies will be used in combined processes for future. Our girls and our very nice students in São Paulo, Brazil. And we believe young people to keep at least some conditions for living and for nature. Go on. Thank you.
Thank you, Dr. Borrely.